So, last class we have explained what is bang control with an example of a numerical example. Let us recap that or review that problem, bang control problems. Let us call our system is given by x dot is equal to a x plus b u. U is the control input. So, our problem is we have to minimize the performance index, that is a 0 to T f dt and this is T f, that minimum within minimum time the initial state of the system, the control input should be such that initial state of the system will drive to the origin in a what is called with a maximum and minimum value of its control signal. Magnitude wise both the signals are same. So, this and also our control input constant is given, that means the magnitude of u should not be greater than equal to 1, it cannot be greater than 1. This is the constant on input signal is given. So, ultimately our problem boils down to transfer the initial state x 0 to the final state in a minimum time T f, that is the thing. So, we will proceed as we have considered earlier, form a Hamiltonian function with the knowledge of the state equation. We form the Hamiltonian function that h is equal to this, and this is the equation number 1, that 1 plus lambda t x t and lambda 2 t of u t. Note this expression 1 is the Hamiltonian function that is expressed in terms of linear terms of u. H is the linear terms of u. So, if you differentiate h with respect to u, the u terms will not present in that. So, we will not be able to find out that u expression for this one, and not only that, that u is our case is bounded by a constraint, that means u of t mod u of t is less than equal to 1. So, if you now write the co-state vector lambda dot this del minus del h of del x of t is equal to this, from there to our first co-state vector is this, and second co-state vector from this expression, if you differentiate with x, partial differentiation of h with respect to x, you will get this one. Now, from this expression you see that lambda 2 dot is equal to lambda 1 dot, and from lambda 1 dot is equal to a constant term lambda 1 with 0. By this one we can see that lambda 2 expression, it depends on the initial value of lambda 0 and lambda 1 0 and lambda 2 0. And since I mentioned you earlier that if you differentiate partial differentiate of this with respect to u, there will be no u terms is involved in the expression, because the h is a h which is a function of u is not nonlinear terms is exist in h of in nonlinear terms of u is present in h. So, what we have to do now, we have to do, we cannot write it that because u is a discontinuous function, either you are switching to 1 or minus 1. So, we cannot differentiate this with respect to u and assign to 0. So, what we can do it, we can minimize Pontian minimum principle, we can apply it. Now, see this term I can make it negative with the choice of lambda is what? If lambda 2 this value is, let us call negative, then we have to consider that u of t is 1. So, this product of this one remains what is called negative. If lambda 2 is positive, then u of t you have to switch to minus 1, that means this product will remain negative. So, with this procedure that we can minimize the what is called the Hamiltonian function in this one. So, this plot is a signum function of u of t, not u of t, lambda 2 of t, lambda 2 of t, signum function of this. we am plotting this one. Next, now let us see, as we told you, this function will be minimum when lambda of t less than 0, we will switch to u is 1. So, this product will be a negative. So, if we put this that u of star is positive, then what is the state equation boils down? We will see x 1 dot is equal to x 2 and x 2 dot is equal to u star of t, u star I put it 1. So, now from this equation I can write it that the solution of this one is that one. Similarly, x 2 x 1 dot is equal to x 2 and x 2 solution I know this, I expressed it here. Now, so if you now integrate this one with respect to dt, then x of t is equal to x of 0 x 1 of 0, this is what is called this x of 0 t and this is t square by 2, and after simplification this you will get this equation. So, x 1 t is equal to x 2 square x 2 square agree by 2 plus x 1 0 minus x 2 square 0 by 2, and this is the constant term that depends on the initial condition of the state where it is. So, this is nothing but a, if you see the equation 6 is nothing but a parabola equation with a constant term C 1 is there. Similarly, if we apply, if we switch the control is u star in minus 1, if I minus 1, then our equation x 1 dot is equal to x 2 dot is equal to minus 1, and the solution of x 2 from this equation is this, and again solution of x 1 dot is equal to this, which solution of x 1 of t is finally this one for u is equal to u star of is minus 1. Now, see this equation also, equation 7 also a parabolic equation with a constant term C 2, different C 2, that also depends on initial value of x 1 and an initial value of x 2. Now, these two equation, now question is when we will switch to u star, when we will switch to u star is equal to, when we will switch to u star is equal to 1 and when we will switch u star is equal to minus 1. So, that the Hamiltonian matrix is minimized with a from the sense of Pontryagin minimization, that Hamiltonian function. So, let us now redraw this one to explain more clearly about this figure. So, if you see this one, so this is the equation, that is what, if you see this is the equation x 1 t is equal to x 2 square of t by 2 plus x 1 0 minus x 2 square 0 by 2, which equal to denoted by a C 1 for E is equal to when it is plus. Similarly, so this is the equation of the parabola. Similarly, when u we switch to u with minus 1 signal, then solution f x 1 is equal to minus x 2 square t of 2 plus C 2. This is your C 2. So, this is also another what is called parabola. So, let us draw these two parabolas. Assume that C 1 is 0. Let us call x 1 dot x 2 dot. You have said in that x 1 0 x 2, so we have selected in such a way, so that C 1 is 0. So, this is simply a parabola equation which passes vertex passes through origin. So, this is the equation, if you see this is the equation for a parabola when the control signal is switched to u is equal to plus 1, and this is the trajectory of x 1 in this direction x 1 and in this direction is x 2 of t. Now, for another initial condition, different initial, the C 1 let us call is positive greater than 0. If it is a positive, if you bring it here, then x 1 minus t minus C 1, C 1 is I have considered positive. That means some value of C 1 x 1 when x 1 is equal to C 1, then this vertex will pass cross the x axis, this one, and this is the parabola when C is, I am now drawing sequence of parabola when C is greater than 0, C 1 is greater than 0 and it is increasing, C 1 is increasing in this direction, C 1 is increasing. That this is for C greater than 0, but u is equal to plus 1. Now, C less than 0, that means when C this quantity is negative, if you bring it to this one x 1 plus C 1. So, some value of x 1 which is negative, that vertex will cross the x axis, agree this. So, and when it is a, so this is our parabola when u is positive, but C 1 value is negative. We have selected the initial condition is such that C 1 is negative. So, this is the cases when C 1 is less than 0, agree, C 1 is less than 0. This is for this equation. Now, for this one, when we switch the control input minus 1, then this is the equation of that parabola or trajectory between the phase plane of x 1 versus response is given by this one. Again, in the similar way, we can say when C 2 is 0, then this is the equation of parabola, agree. This is the equation of parabola which shows by so this curve is C 2 is, this curve is C 2 is 0, agree. Now, C 2 is positive quantity, let us call C 2 is positive quantity, then x 1 minus C 2 in reference side, then what value of x 1, what value of x 1, this left hand side will be 0, some positive value of the. So, C 2 positive is this curve parabola and C 2 greater than 0, C 2 greater than 0 is this curves. And when C 2 is negative, when C 2 is negative, then x 1 plus C 2, that means it will this parabola will cross the x axis in the negative directions. So, this is so this is C 2 is less than 0 and this is all the curves C, that is C 2 is greater than zeros. Now, this is the trajectories we have done for when the control input switch to plus 1 and when the control input switch to minus 1. This switching, what is the proper way of sequence we have to switch plus u is equal to plus or u is equal to minus. Let us call we have a trajectory here. Let us call we have a trajectory, we have a initial point is here somewhere here, that is our x 1 of 0 and x 2 of 0. This is our initial point x 1 of 0 and x 2 of 0. Now, question is which direction the trajectory will move, or at that point whether we will switch to u is equal to minus 1 or we will switch to u is equal to plus 1. Now, if you see here, if you switch the u is equal to plus 1, if you switch u is equal to plus 1, then our trajectories, if you see that our trajectory at this point u is equal to plus 1 is like this way. So, when u is equal to plus 1, u is equal to plus 1, the trajectory is like this way. Now, x 2 is positive, x 2 positive means x 2 positive. If you see the basic equation of this one, x 1 dot is equal to our case is x 1 dot is equal to x 2. So, our basic equation x 1 dot is equal to x 2. So, our basic equation is x 1 dot is equal to x 2. Agree? So, if x 2 is positive, then x 1 tends, it will increase it will go this side. So, it can go this side, again x 1 is positive, sorry, x 2 is positive, again it will increase. So, the trajectory will go from initial condition away from the origin. So, at initial point we have to, if we switch to u is equal to minus 1, then trajectory is the blue one. So, this, that means this one, it will follow this curve, because u is equal to minus 1, this is the trajectory for this one. So, if you follow this one, then you see this is the, it is when x 2 is negative, as x 2 is positive, x 1 dot is positive, it indicates x 1 dot. So, x will increase, then x 2 is decreasing and x 2 is decreasing, but its value is positive, still it is increasing. Now, when it is x dot is negative, here x dot is negative, so x should decrease it. So, it is decreasing. So, when it hits here, when it hits here, when it hits at this point, you have to switch to u is equal to plus 1, then trajectory will move along this way. So, our optimal time required to drive the state from this point to origin is this is the optimal, rather I can draw it, this is the optimal trajectory. It will hit this one, u is equal to this indicates this trajectory, it approaches to 0 when C 2, when this is the C, you see this one, the C is 0. So, this is C 2, so C 1 is equal to 0. So, it will come this one and it will go like this way, and it will come origin in this one. So, this is the optimal trajectory, in minimum time it will reach to origin, if it is. Now, similar logic you can put any point in the trajectory, any point in the what is called phase plane. Agree, you have a initial condition is there, where it will switch initially and final stage where it will switch, whether u is equal to minus 1 or plus 1. So, we will summarize the results our things like this way. Let us consider that our C is equal to 0, there are two parabolas are there, agree. When C 1 is 0, if C 1 is 0, it passes through origin. When C 2 is 0, it also, this parabola also passes through the origin. The segment of two parabolas, the two portion of segment of this parabola passes through the origin, and this equation we can write like this way. The segments of, you see, the segments of two parameters, two parabolas, segments of two parabolas, this is the one parabola and this is the another parabola, which is passing through the origin. For C 2 is equal to 0 and this is for C 1 is 0. Segments of two parabola through the origin form a switching curve. So, this is our switching curve. So, this is our switching curve. Now, what is the equation of this one and what is the equation of this one? When C 1 is 0, if you see when C 1 is 0, our equation is, just I am writing, when C 1 is 0, our equation is x 1 of t x 2 of t this plus C 1, which is equal to, I assume 0 for u is equal to plus 1, and this is x 1 t is equal to minus x 2 square t by 2 plus C 2, this is equal to 0 for the is equal to minus 1. So, this two equation is nothing but a equation of this one and equation of this one. Now, I want to write this is our switching surface or switching line. Okay. So, these two equation combinedly I can write it now. If you see that S is equal to switching in this x 1 of t plus half x 1 x 2 square of t sine signum function of that x 2 of t. Look this expression, when x 2 is positive, when x 2 is positive, this is the switching surface. When x 2 is positive, in this region x 2 is along the surface, x 2 is positive is here, x 2 positive here. So, when x 2 is positive, that means sign of this positive and this is also positive. So, x 1 plus t plus this one, then in this case the x 1 t plus x 2 square by 2, this is expression when x 2 is positive. That means, when x 2 is positive, it is represent this surface. When x 2 is negative, that negative sign will come, that means x 1 minus half x 2 square. So, x 1 if you take this side minus half 2 square, it represent this parabola, means when you have switched to u plus 1, that means this is the u plus 1. Agree? So, where we want to switch one? So, I just these two equation also one can write it x 1 t plus half x 2 t plus mod x 2 of t, this and this equation are same. Agree? That switching surface, suppose any point on this surface, S is equal to what? 0. So, therefore, any point on the switching surface S is equal to 0. So, now if a point here, what is the value of S? If point is here, if you look at this expression, that S will be greater than 0. How? Now, you see, suppose it is the point is here. So, x 2 a point is here, x 2 is what? Negative. X 2 is negative. X 2 negative means this is negative. X 1 minus this. So, u is equal to plus 1. That x 1 minus this is equal to 0. Now, it is just below this one or anywhere below this line or above this, not below, above this line, anywhere above this line. This is the switching line, anywhere above this line, you can see from this expression, that S is greater than 0. So, we will write. So, now we will define S function of time, a function of x is equal to x 1 of t plus half x 2 square, either you can write signum of x of t or it is same as x 1 of t plus half x of t mod x 2, this is 2 of t. Agree? So, if s is greater than 0, s is greater than 0, what does it mean? This means s is greater than 0, this means that it is above the switching surface, above the switching surface. So, x t lies above the switching curve A O B. This switching curve I define the name is A 0 O and this is B. This is the AOB above the. And in this case, if it is a if the initial condition above the switch, now I make a conclusion, in initial condition if it is above the switching line, that means anywhere here, then initially you switch to u is equal to minus 1. Agree? If you switch to minus 1, suppose it is here, it will switch to minus 1, it will come here and it will hit here, then it will go to the origin here. Suppose it is the initial condition is here. So, it will come to this one, you have switched to minus 1, it will come here, hit here, and when it hits the switching surface, then you put u is equal to plus 1. So, it will go like this way. So, the two switching you have to do it. So, now I am writing this is above the thing. In this case, u is equal to minus 1. If x is above that, switch to minus 1 because, or you write it, switch to u is equal to minus 1 because the blue curve parabolas are directed towards the switching curve. That means, when it hits the switching surface, then you switch to plus 1. So, our switching is minus 1 plus 1 when if the initial point above the switching surface, that means, if our initial state above the switching surface, first you switch u is equal to minus 1, then when hits the switching surface, then switch to u is equal to plus 1, then your state will drive to origin in a minimum time. So, now if s is less than 0, from this figure, from this equation you can see if s is less than either of this or this, you can see if s is less than 0, x t lies below the switching curve AOB. In that situation, you switch first to see here. Suppose it is below the this one, some point here. Agree? So, you first switch to u1. If u1, if you switch it, and this is the curve. You switch to u1, then it will follow this one, and once it follows this one, it hits here the switching curve. And when it hits switching curve, u is equal to minus 1, and then it will follow like this way. That means, if it is there, it will move like this way, and then it will come back to this way. So, switch to u is equal to plus 1, because the red curve parabolas are directed towards the switching curve. So, our switching is plus 1 minus. If it is below the switching, first you switch to plus 1 u, then you switch to u is minus 1. So, this is our sequence. So, that is what we have discussed last class. Then, so if you see, recall, our switching curve is, that one is our switching curve. This is C 1 is 0 and this is the C 2 is 0 and this is for u 1, u is plus 1, agree, and this is u is minus 1 and this is the switching curve. When trajectory hits here, it will go along this one. If it hits here, it will go along this one. So, if it is above the initial condition is above the switching curve, then first you switch to u is equal to minus 1, then it will hit here. When it will hit here, this is u is equal to plus, it will go to the origin in this fashion. So, this is your switching curve for this one. So, that is we have discussed last class is done. Now, how to implement? Now, tell me this one, if it is whether it will lies here or not, how will you check it? Check is there, you find out the value of s. If the value of s expression we have given it, this is the x expression, you find out the value of x. If s expression is very small, let us call mod of s is less than 10 to the power of minus 4, and not only this one, and if you see x is, if it is less than this and x 2 is greater than 0, if it is x 2 is greater than 0, then if x 2 is greater than 0, this is the x 2. If x 2 is greater than 0, that means which one? Here x 2 is greater than in this switching region, x 2 is greater than 0 and s is along this curve, the s is 0, is very small, that means mod of s is less than 10 to the power minus 4 like this, then you switch to what is called u is equal to minus 1. Similarly, if s is 0 and x 2 is negative, then you switch to u is equal to plus 1 again. So, another situation you can write, if s is equal to 0, say mod of s is 10 to the power of minus 8 something is equal to mod of and x 2 of t is greater than 0, that means x of t means x 1 t, x 2 t lies on the, if this and x 2 is this is x 2 lies on the switching curve AO. S is 0 and S is greater than J, that means it is lies on the switching curve. This is, if S is 0, mod of S is equal to 10 to the power minus 8 and x 2 of t less than 0, then x t curve lies on the switching curve, on the switching curve BO, this one. This is mod of S very low, but x 2 is negative, then it is lies to the switching curve. So, in this way you can check it, then when you will switch to the u plus or u minus. Starting from u plus, when you will switch to the u minus, that you can check by satisfying this condition. So, now our next topic is briefly I will just tell you now how to implement this control law. You have to see how to implement that control law. So, you have a plant, and plant is given plant is x dot is equal to x 2 and x 2 dot is equal to u of t, and this is our control law we have generated. How it will generate, that will show control law. That means u star of t, and this is our state x of t, which is equal to x 1 of t and x 2 of t. And this is we have taken with the knowledge of these two states, we are implementing this. So, this is the implementation of, you can say the figure is implementation of bang controller, bang controller via state feedback. Now, what is the u? We have selected u of t is equal to minus 1. I will select u of t is minus 1 when s of x t is greater than 0, agree, s of x t is greater, that means above the switching surface if it is there, then switch to when this, and then plus 1 when this is s, when s of x t is below the switching surface, and plus 1 will switch when, again we will do when x s of this mod of this is less than equal to epsilon, and epsilon is, let us call 10 to the power of minus 8, and x 2 of t is less than 0. So, you just write when x of a is greater than 0, then drive, and then state will directed to the what is called to the switching surface, and then you consider, then from this one you write this is next this. If so, when it will hit the switching surface, I will check whether it is hit or not. S value should be very small, 10 to the power minus n, and x 2 minus it will be negative. So, minus 2 plus it is switched. Again it is switched to place when s of x t is less than 0, and it will be switched to minus 1 when s of t is less than equal to epsilon and x 2 is greater than 0. So, this way you have to write the logic to switch that one. So, how do you implement in these things, one can see more clearly. Suppose we have a second order system, what we have considered, that is 1 by s, that another is 1 by s, then this output this is your u star of t, and this output will be a x. If you see x, this output will be x 2, because x dot is x 2 dot is equal to u. So, this is x t, and this output of this one will be x 1 of t, and this is going here, and from there we are taking a signal which is half x 2 half, and another we are taking this signal. This is absolute of x 2 of t function, and these two outputs is multiplied, this t signal is multiplied. So, I am at half x 2, then this signal absolute value of this is multiplied, this is the multiplied, then this signal is going to the summer, and this is our this x 1 x 2, this is our input, not input, that is our signal, and that signal, if it is a -1, then you with a delay. Agree? Now, you see this one, this is our S. So, this is our S, that x 1 plus half x 2 S 2. So, half x 2 into mod of x 2 this, and this signal, this is summed, and this signal multiplied by -1. Now, I am checking that one, if it is a greater than this signal, if you consider this signal is z, if this signal is greater than 0, then this is +1, if it is greater than less than 0, it will be a -1, and this output is the output of that one. Now, see this one, I told you this that signum function is taking care of that one, and then it is a ideal relay is kept it. So, this signal, if it is, if this signal multiplied by this -1, if it is a greater than 0, then it will switch to 1. Again, and if it is less than 0, then it will switch to -1. So, this is the implementation of that control algorithms for bang control. Now, if you see this one, that this S I have implemented it here up to this. Now, question is what? If S is positive, I told you if S is positive, then you switch to -u. So, if this is positive, if S is positive, you switch to -1. So, if it is a this signal, if you directly put it, then it will switch to 1. That is why you have multiplied by -1. So, it should take care of u is equal to, if S is negative, then it will switch to +1. If S is positive, it will switch to -1, that one. So, now, next is our topics that what we will consider. We have considered the constant in input signal. There may be a situation where the state variables also we make constant on the state variables. Then how to solve such type of problems? That means constraint in control input and state variables. So, our problem is, consider one controller is subject to saturation. That means, u of t, absolute value of u of t is less than equal to belongs to u of a. For all t belongs to t 0 to t f. So, we made a constraint on the u, that means, that u belongs to that u a, and also second condition on the constraint on the state variables, the constraints on the state variables. State variables. State variables. That constant, let us call, we have there are L constants are there in the state variable. Out of n state, there are n constants are there. Let us call n L constants are there, x of t comma t, this is less than equal to 0. So, our first constraint is that one, equation number 1, second constraint is this equation number 2. So, and we are assuming that psi is continuously differentiable with respect to x, that psi is continuously differentiable with respect to x of t, that is the mean. So, we have a problem, let us call x dot is equal to a x plus b u. Then we have a constant on the u, that u mod of u, let us call scalar input, mod of u belongs to u of a is given. Then this is the constant on control input. Then state variables, we have a state variables and constant, let us call x 1 may be greater than 0 and x 2 may be range minus 2 to plus 2, all these in constants are there, and that psi of this function is differentiable, that one. So, our technique is, the simple technique is convert this thing into a inequality constant, convert into a equality constant. So, a technique is to convert equation number 2 into equality constraint. So, what we did it, we introduced a new state variable, we introduced new state variable. New state variable n plus 1th new state variable. Suppose we have a system whose dynamic system matrix A whose dimension is n in n, that means x of t whose dimension is n cross 1. So, you have introduced a new state variable this, and u has a, let us call u of a scalar quantity 1 cross 1 scalar quantity. So, we have introduced that one, we have introduced that x n plus 1 dot is equal to f n plus 1 of function. What is this one? that what is the constant equations are there, psi 1 x of t this whole square into another function u s of psi 1 of t. This is minus, there are another constants are there, psi 2 of t x of t comma t whole square psi 2 of this, and in this way we have a L constants are there, psi L x of which is a function of x, psi is a function of x and t square by psi x psi L dot 0 this. So, let us call this is equation where u s psi I of x of t this is a strict unit function, unit step function, and it is defined at u s is equal to psi of x t of t is equal to 0 when value of that constant value x of t this and this is less than equal to 0. For what is this? This is the constant, when this constant less than equal to 0, then this is 0 and this is equal to 1 for psi of x t of t greater than 0 and I is equal to 1 2 dot dot L. So, this is equation number 4. So, now see this one x n plus 1 star of t is less than equal to 0. When it is less than equal to 0, from 3 and 4, from 3 write it from 3 and 4, from 3 and 4. When this is equal to less than equal to this, if it is less than equal to 0, if this constant is less than equal to 0, agree, then this term is less than equal to 0, this, then this term will be what? If this is less than equal to 0, then u s value will be what? This is a positive quantity less than equal to or 0, but but is preceded with negative. So, it is a negative quantity, but u s of is if it is less than 0, then it is a unit step, strictly unit step. So, this value is 0, this value is 0, this value is 0. If all this function is less than equal to 0, then this equal to 0 for all t. Now, x n plus 1 dot t is equal to 0. Now, tell me when it will be 0? This quantity will be 0 when? If this is greater than 0, that means psi of this is greater than so, if this is greater than 0, let us call, then psi of this what greater than 0, this 1, and this will be a okay, let us say. So, this if it is this is less than equal to 0, then psi of this that is u of is 0. So, if it is a negative quantity, let us call this is negative quantity, this is positive, but this quantity is 0, and this quantity is similarly if all the when it will be a less than equal to 0, this is 0, this is 0. No, and when it will be less than equal to 0, let us call when it will be when psi is let us see, when psi is greater than 0, when psi is greater than 0, then this quantity is positive, this is negative, but this quantity is 1. This quantity is 1, this quantity is 1, this quantity is 1 for that psi of s dot is value is 1 for when psi I dot is greater than 0. If psi I is greater than 0, then this quantity is 1, 1, 1, all are negative, all are negative. So, this is 0 for all t, and this is equal to 0 only at those times when all the constraints psi I of x t of t is less than equal to 0. If it is less than equal to 0, this is because it is maybe 0 negative, this is a negative quantity, but this quantity is 0. So, this will be 0 for all values. If it is less than equal to 0, psi 1 is less than 0, psi 2 is less than 0, then this quantity is 0 for all times. But if this is not equal to less than 0, it is greater than 0, then if it is greater than 0, then this quantity is 1, this is negative, because it is always greater than equal to 0 for all t. So, we will stop here today. Next class we will continue this course once again.